Okay, I'm back, and now we want to talk about what does the ocean floor look like. And so a lot of people thought that, well, it would be very muddy down there and it'd be very flat and very featureless. Well, boy, were they in for a surprise. Because, for example, during World War II, when various ships were trying to detect German submarines, a lot of the time they would just leave their sonar on all the time, and they would be mapping the bottom of the ocean floor. So the idea of sonar is it sends down sound waves from the ship, and then it bounces off whatever it runs into, and then it comes back up to the ship, and by measuring the amount of time that it takes for the sound wave to get down there and then to come back up, and if you know the speed of sound in the water, you can figure out the distance that the sound wave traveled. And so they left their machines on, and they were essentially mapping all of the various contours of the ocean floor. And so eventually they made a map that looked like this. So this particular map was made by National Geographic way back in probably the 1960s. And I can remember that back when I was in elementary school, I looked at this map and I was just fascinated by it. The fact that there were mountains on the ocean floor and there were trenches, and so you had all of these different geological features, and I wanted to know what caused it. And so this picture was actually what got me started in science all those years ago. All right. So what are some features on this map that are going to be interest to us as geologists? Okay, so the first one is that it's going to have ridges and fracture zones. Okay, so let's go back to here, and you'll notice that going down the middle of the Atlantic Ocean, so in between North America and Europe, and in between South America and Africa, is this ridge. It's a series of volcanic mountains, and these mountains are as tall as the Rocky Mountains in the western United States. But yet, they are so deep in the ocean that they're covered up by like a mile of ocean water. So you got the ocean, and then it goes down for about a mile, and then you start to get to these volcanic mountains. Okay, now look at those volcanic mountains, and you'll see that they go in between North America and Europe, and then South America and Africa. And then do you see how they go around Africa? And then they also go around South America, and then there's another series of volcanic mountains off the western coast of South America. So it's almost as if these mountains form like the seams of a baseball that wrap around the earth. Okay, now they're volcanic, so they have volcanoes, and they are erupting material underwater. Okay, another thing that you should notice about these mountains is they've got cracks in them. So that you've got the series of mountains, but then you'll also notice that they've got the series of cracks in them like this. So whatever theory that we come up with that's going to explain plate tectonics is going to have to explain why are these mountains there, and then also it's going to have to explain why does it have these cracks that go across them like that. Okay, another one is trenches and island arcs. So that if we go back to here, this time we're going to be interested in the Western Pacific. So in the Western Pacific, what you will notice is that there's a lot of trenches. And these trenches are so deep that you could put Mount Everest into the trench, and then the top of Mount Everest would not come out of the trench. So there are very, very deep trenches in the Western Pacific. One of the deepest trenches is the Marianas Trench, for example. And then another thing that they noticed that was right next to these trenches were a string of islands. And so they wanted to know, is there a relationship between the trench and the island chain that is right next to the trench? Another thing that they noticed was that these trenches and these island chains tended to make curves. So they tended to make arcs. So whatever theory that we come up with is going to have to explain the curvingness of some of these features. Okay, then the third thing is seamount chains. So that in the middle of the Pacific Ocean, there are strings of islands that form a chain, and they're in a straight line. Okay, example of this would be Hawaii. So if you look at Hawaii, you got the big island of Hawaii, and then there's another island next to it that gets a little bit smaller, and then another island next to it that gets smaller. And then if you drain the water away, you're going to find out that there are more islands like this, and they form a linear structure. So they're forming a line. And so these islands are under the water. So the question is, well, why would these islands be out of the water? Why would these islands be under the water? And then if you look closely, you'll notice that those islands, they abruptly start going north like that until you get to the Aleutian Islands off the coast of Alaska. So whatever theory that we come up with is going to have to explain why it has that turning motion to it. Okay, so evidence for seafloor spreading. So let's take a break, and when we come back, let's talk about this.